Let's revisit our discussion of principal and interest on loans. Recall that if we borrow P0 dollars for T years with an annual interest rate of R, then the amount owed P can be found by P of T equals P0 times 1 plus R to the T. In our example, we borrowed $100,000 with a 10% annual interest rate. Then the amount we have to pay back after T years we found to be P of T equals 100,000 times 1 plus 0.1 to the T, or P of T equals 100,000 times 1.1 to the T. But what if the bank wants to collect interest after each month instead of waiting a year? In the real world, this is typically how car loans, mortgages, and other loans usually work. So in this new scenario, where the bank collects interest each month instead of each year, we need to find a new formula for P of T. As we did previously, let's start by finding P of T for certain values of T. Let's start with T equals 1/12, because P of 1/12 is the amount owed after 1/12 of a year, which is 1 month. So P of 1/12 equals the $100,000 that we borrowed plus $100,000 times our 10% annual interest rate divided by 12. Note that we have to divide it by 12 because 10% is our annual interest rate. So after 1 month, only 1/12 of 10% is earned in interest. Factoring out $100,000, we can rewrite this as 100,000 times 1 plus 10% over 12. As with our last example, rewriting it this way will prove to be useful. Evaluating P of 1/12, we get that after 1 month, we owe $100,833.33. So how much do we owe after 2 months, or when T equals 2/12? Well, P of 2/12 is the amount we owed after 1 month, the $100,833.33, plus the amount we owed after 1 month times 10% over 12 for the next month's interest. Factoring out the $100,833.33, we get that P of 2/12 is $100,833.33 times 1 plus 10% over 12. But we can rewrite $100,833.33 as P of 1/12. So P of 2/12 equals P of 1/12 times 1 plus 10% over 12. But P of 1/12 is 100,000 times 1 plus 10% over 12 times 1 plus 10% over 12, which we can simplify as 100,000 times 1 plus 10% over 12 squared. Evaluating this, we get $101,673.61. So far, we found that P of 1/12 is 100,000 times 1 plus 10% over 12, or in other words, P0 times 1 plus 10% over 12. P of 2/12 is 100,000 times 1 plus 10% over 12 squared, or in other words, P of 1/12 times 1 plus 10% over 12. A similar calculation shows that the amount owed after 3 months is P of 3/12 equals P of 2/12 times 1 plus 10% over 12. But P of 2/12 is 100,000 times 1 plus 10% over 12 squared. So in all, we get that P of 3/12 is 100,000 times 1 plus 10% over 12 to the third. So far, we found that P of 1/12 is 100,000 times 1 plus 10% over 12. P of 2/12 is 100,000 times 1 plus 10% over 12 squared. P of 3/12 is 100,000 times 1 plus 10% over 12 cubed. If we follow this pattern, how much do we owe after 1 year? P of 1 is 100,000 times 1 plus 10% over 12 to the 12th. Why? Because for each of the 12 months, we need to multiply $100,000 by 1 plus 10% over 12. If we carry this pattern further, we find that P of 2, the amount owed after 2 years, is 100,000 times 1 plus 10% over 12 to the 2 times 12 for the 24 months in 2 years. Let's use what we found about P of 1 and P of 2 to figure out what's happening in general. How much do we owe after t years? P of t equals 100,000 times 1 plus 10% over 12 to the t times 12. Notice that since t is in years, t times 12 is the number of months. So we found that if we borrow $100,000 with a 10% annual interest rate, with interest collected each month, or compounded each month, then the amount owed after t years is P of t equals 100,000 times 1 plus 10% over 12 to the t times 12. How much money do we owe after 3 years? P of 3 is $100,000 times 1 plus 10% over 12 to the 3 times 12, or 36. This comes out to be $134,818.18. So after 3 years, we owe $134,811.18 when interest is collected each month. Let's compare what we just found to what we found when interest was only collected at the end of each year. When interest was collected each year, we only owed $133,100 after 3 years. This is a difference of $1,718.18 just from collecting interest more often. So a greedy banker would want to know, what if the interest is collected even more often? To figure this out, let's look at what we just found. In the last example, interest was collected each month, which is 12 times per year. What if we collect interest each day, or 365 times per year? Then the new formula is P of t equals $100,000 times 1 plus 10% divided by 365, all to the t times 365. In general, if we borrow P0 dollars for t years with an annual interest rate R and interest collected or compounded n times per year, then the amount owed P is P of t equals P0 times 1 plus R over n to the n times t. In general, if we borrow P0 dollars for t years with an annual interest rate R and interest collected n times per year, then the amount owed P is found by P of t equals P0 times 1 plus R over n to the n times t. Note that when we collect interest n times per year, we say that interest is compounded n times per year. And we found that the bigger n is, the more money is owed. So what happens as n goes to infinity? We call this compounding continuously. In this case, the amount we owe keeps getting bigger, but not infinitely big. And the formula comes out to P of t equals P0 times e to the RT. So we found that if we borrow P0 dollars for t years with an annual interest rate R and interest compounded continuously, then the amount owed is given by P of t equals P0 times e to the RT. Let's look at an example. How much will we owe after 5 years if we borrow $15,000 with a 6% interest rate compounded continuously. The phrase, how much money will we owe after 5 years, is asking, what is P of 5? Using the model we just found, P of 5 will be 15,000, our original amount, times e to the 0.06, or 6%, times 5 for the 5 years we borrow it. Evaluating this, we get $20,247.88. So we will owe $20,247.88 if we borrow $15,000 with a 6% interest rate compounded continuously for 5 years.